Hello. Hope you are able to follow the outcome-based education course and you are able to define your course outcomes, program-specific outcomes, and program outcomes also. But program outcomes and program-specific outcomes you can decide only with a high-level meeting. And you now know how to assess your course outcomes also. But when we are into a true outcome-based education framework, the assessment activities, I could say the examinations or assignments or whatever assessment activities we do, we must be able to assess the attainment levels of outcomes of our students. So the questions for our assessment activities have to be drafted in such a way that these questions will be assessing the attainment of outcome levels of our students. So I will give an example. I will show you a sample question paper. So when we use it, suppose you are teaching taxation. Previously, you might be asking the different rules of taxation or different income tax rules like that, but what is the slab deduction rate or something like that you may be asking. But if you are in outcome-based education, we may be giving an actual salary statement of an employee for a taxpayer for 1 year. And then we may be giving his housing loan repayment, housing loan interest, other savings, and all details we will give. And we'll be asking the students to prepare the final tax statement for a taxpayer. And if he is able to prepare that tax statement, all theoretical aspects he may be knowing, and the meaning that if he is able to do this, he has learned that, he has achieved the outcome. So like that, we must be, while drafting the questions for our assessment activities, we must be ensuring that these questions are assessing the attainment level of our course outcomes attained by our students. So I will give you an example. This is from a computer science subject, but hope you will be able to follow this. So this subject, which if we use the NAC terminology, this course is design and analysis of algorithm. So this involves some design methods of algorithms and analysis methods of algorithm. We are teaching the students to analyze algorithms based on the storage space required for storing those algorithms and converted into a program. Or we are teaching them to analyze the execution speed, how fast the algorithm will be when it is converted into a program, because we can solve a program. We can write an algorithm for solving a problem in many ways. So which will be the optimum method of deriving the algorithm, so that we are teaching them to analyze. So previously, when we were not following the outcome-based education framework, we were asking questions like define space complexity, define time complexity, and how do you express the time complexities, define an algorithm, and what is knapsack problem, what is all pairs shortest path problem. Like this, we were asking direct questions, and these questions were reaching only the first or second levels of Bloom's taxonomy. And now you see this question paper, which we are in the process of analyzing. You see, we are dividing the question paper itself into course outcomes. So first section is for course outcome number 1. Second section is for course outcome number 2. Third section is for course outcome number 3. Like that, we have 5 sections for 5 course outcomes. And then again, in course outcomes, we have 3 different types of questions. These questions are addressing, or this is trying to evaluate the attainment level of outcomes at level 1 or 2 of or lower levels of Bloom's taxonomy. And these questions, we could say, this will be trying to evaluate maybe a middle level of Bloom's taxonomy. And finally, these 6-mark questions are trying to address the upper levels of create and evaluate and create level of Bloom's taxonomy, apply and create level of Bloom's taxonomy. So this way we have group the questions into three categories within course outcomes, indicating lower levels, middle levels, and higher levels of Bloom's taxonomy. And then this question, previously this question would have been, what is time complexity? That would have been the previous question, because this is analysis of an algorithm based on its execution time. But now we have rearranged the question in such a way that two algorithms have got complexities big O of n and theta of n respectively. Compare the performance of these algorithms. So if this particular student wants to answer this question, then he must be knowing all the theoretical aspects, and he must be knowing what is the difference between big O and theta of n, and also what is the application level, how these algorithms will be if the time complexity is like this, how the algorithm, the performance of algorithm will be varying if these complexities are like this. So if you see this second question also, I'll just show you. Critically evaluate the statement, linear search has got theta, big O, and omega time complexities. So previously this question would have been like this: what is the time complexity of linear search? But this, if they want to answer this question, they must be knowing the art of analyzing the time complexity of linear search. Then only he will be able to answer this question. So this way we are addressing the Bloom's taxonomies and course outcomes of this design and analysis of algorithms. And when we come to the higher order of Bloom's taxonomy, explain how recursive algorithms have more space complexity with the example of max-min. So this is really an application-oriented question, because in programming, we have two ways of writing programs, by using recursion and by using non-recursive methods. And when we use recursive methods, it needs some additional resources. So by using this example, by applying this example, a student has to demonstrate how it is occupying more space. And if you come down, I will just show you how this application level questions are drafted in this particular subject. So this is an application level question. Develop the cost metrics for 5 cities represented in the graph. So if we, this is really, he is applying his knowledge. A graph is given and he has to develop the cost metrics. So if he is able to develop the cost metrics, all the theoretical aspects will be it follows, because without knowing the theoretical aspects, he will not be able to develop the cost metrics for this particular graph. And then we have this course outcome number 3 and different types of questions. And if you, this is a application level question for course outcome number 3. So consider the cost metrics for 6 cities given in the following figure. Draw the minimum cost spanning tree of the corresponding graph using Prim's algorithm. So here a cost matrix is given, and he has to, he must be knowing how the graph theory can be applied to convert this cost matrix into a graph, and later an algorithm design technique has to be converted into drawing a spanning tree of this. So this is really an application oriented question and raising at the higher levels of Bloom's taxonomy. And also I will show you a few more examples of higher levels of Bloom's taxonomy. So this is a higher order question. Explain the working of breadth first search algorithm in the following graph. Illustrate the creation of the queue during the execution of the algorithm for this graph. So they have to apply the BFS algorithm on this graph, and also they have to show the intermediate processes of applying the BFS algorithm, and finally a tree will be generated, and how this tree can be generated from this. So like this, all these questions, I am just browsing through the question, you can see all these questions are all application oriented questions, and none of these questions are directly testing the what the first two levels of Bloom's taxonomy, remember or understand, because we are, when we move to the higher levels of Bloom's taxonomy, all these questions are application oriented questions. So we are testing whether the student will be able to do something after learning that subject. So this is really a change in the assessment activities. Also, when you draft your questions, you must be what designing a lot of application oriented questions, so that you will be able to assess what the student will be able to do at the end of this course. And so all these questions you can see here. Also we are giving them a graph, and we are asking them. So this question wants to conclude. Here we are saying a traveling salesman has to start from a city number 1, and the students have to suggest a optimum route for the traveling salesman, so that he will be visiting all the cities, and finally he will be coming back to the city number 1 with the minimum cost. So all these questions are application oriented questions. So this way, when we design questions, we must be giving more importance for application oriented questions, so that when a student answers this, we will be able to evaluate whether he has achieved the course outcomes or not. So this is, I hope this video will help you to derive outcome based education questions. Thank you.